I am expecting the output from that particular database. So that what happens, on the data, so whatever the student database information system is there, that it is going to be fetched and it is going to be displayed in this. Okay, this data driven modules is going to show the sequence of actions. The proper information should be there. See, to get the data from the database, first the database should be on, okay, and it should be in the open state. Then after, the data should be present in that. After that, the action, whatever the time we are going to give it from the external state, that is getting processed over there. Then finally, when it gives the output, then the database should get closed. So this is what the expected from the data driven modeling. So one of the activities that is you might already studied in the module 1, insulin pump operation. So this is a proper way of completing the activity. Okay, so here blood sugar sensors are going to be there. Those are communicates with the get sensors values. Okay. So sensor value data is going to be taken and the compute level, that it is going to sugar level is getting computed, and based on that sugar level things, blood sugar level, the instructions to be given to the insulin pump. So for that we have to calculate the insulin delivery. So insulin is going to be sucked in that, and the instruction should be given in such a way that how much dosage that it should suck and should be given to the patient. Okay. So insulin requirements, it's going to be checked, then pump, for the pump that instruction should be given, then pump is going to extract that information and the insulin pump is going to be present over there. Means from that it is going to extract and it should be injected finally. So this is the process really. What we are going to do in this, first is we will be going to check for the sugar level. If the sugar level is down, we should give the insulin. If the sugar level is high, we should stop that instruction, that is insulin. So these two things are going to be given to the function. This is another way of representing the data, that is diagram, that is sequence diagram. This is okay. This is another way of representing it. This is example of order processing it is. Now you see that there's a purchase officer is there, then so those are the objectives, objects are there. Okay. That is order, then object is there, budget is there, then orders are going to be stored in the database, then supplier is there. Okay. So two peoples are going to be present here. One is purchase officer and there is supplier. Purchase officer is going to fill, okay, the data, and it is going to be checked in the order to validate it. Okay. So after the validation, it is going to be validated, data is going to be okay, then update the amount, the budget it goes. Then in the order it is being saved as these things are getting validated and it should be saved in the databases. Then after that it should be sent to the supplier. And the orders that should be sent to the supplier. These are the serial way that it is going to happen and is getting processed. Event driven modeling. Basically event is nothing but a stimuli. So here the actions are going to be present in this. All the actions are going to be present whenever whatever the system that wants to respond. So the action should happen. For example, when you will be going to, now one example, take username and password. Okay, then there's a submit button is there, cancel button is there. So when you say both username and password, if you enter, then action is nothing but you have to submit button that you have to press. If you have not written either any one of this, that is a username or password, okay, then this button, submit button, should not be in the on state, means active state. If it is going to, if it is pressed, okay, something should not happen. So there is a, again testing is going to be there in that. Now everything is entered properly. Then if you press that submit button, then the event is occurring. That is nothing but a click event. Once that event is going to occur, next page that it will move, whether it is moving or not, that is going to be checked. So event driven modeling is nothing but the actions will be there in that, and based on the action the activities are going to be considered. State machine model. So exactly which state that system is going to be. So whether it is the internal and external events are going to happen. So in which state that it is going to be. Whether it is a active state or passive state. Active state is nothing but it is in the exactly that it is moving according to the events. If passive state is nothing but any problems are going to occur, it will be in the stop state. Okay. See that state diagram of the microwave oven. So diagrams are going to be shown. State diagram it is going to be. Okay. Now the microwave operation that you must know for this. Okay. Then only you can able to write this diagram. Now you see that waiting for the display. Okay. Waiting is nothing but display time. The function is going to be display time. Half power work that it is going to be getting executed, or full power it is going to execute. In the half power, okay, set power to 300. So you will be going to set it. In the full power, you set the power to 600. When it is going to be, the full power is going to be there, set the timer. Okay, timer is going to be set, and the functions are going to be get number and set the time. You will be going to set the time as well as numbers is going to be shown in that. So it will be repeated because 10 seconds, 30 seconds, 40 seconds, like that you will be going to set. So set time is going to be, it is executing in that. Okay. So from half power, if it is going to be there, you should move to the full power. It depends upon the system it is going to be. Okay, how much time that is required, basically based on that it is. Then the next you have to, after setting the time, that you have to close the door. Then after closing the door, the display is ready to execute. Start the oven. The operation is going to be, oven is started. Then once the oven is going to start, okay, process is done. If it is properly, if it is running, okay, after the operations, door is going to be open and waiting for the display, and the function is disabled. Okay. Next, if in between that operation fails, okay, so you have to make the waiting and display, you have to display the time. So these are the functionality that you will be going to get it in the microwave operation for the state diagrams. The same thing that it is going to be present here, the state diagram, alarm and all these things that it is going to be written in this. That's it. Okay. Those things is represented in the form of tables. Whatever I discussed, those things are being represented in the form of tables. Okay. Next is model driven engineering. Model driven engineering. So this model driven engineering is the models are going to be executed, okay, in the development process. So you'll be going to models rather than the programs. Individual programs, they are not concentrating directly, they are going for the individual models. Under the model there are so many programs will be there. So not only the programs, the hardware and software programs are going to be present. Okay. Automatically that is going to be executed in the model. Once you model, you will be going to execute. All these things are going to be get executed. Okay. So in the model driven engineering, it gives the abstract information about the process. Abstract information about the process, which are the language that is going to be used, and all these things, the detailed information are going to be available in the next phase. How this model driven engineering works, basically, where and all that is going to be used, what is the advantages of this, and what are the problems that it is going to face. So let us see in this. So model engineering is the early development stages that it's going to work. So the process